Welcome to today's Oracle Machine Learning Office Hours session. Our topic today is Get Started with Oracle Machine Learning, Build and Deploy Your First Model. An abridged version of this session was delivered at Cloud World last month, and we're delighted to share this content with you as part of our Office Hours series. Now, in this session, Helly and I will introduce machine learning use cases. First, generally, and then Helly will cover two specific scenarios. First, use cases from Finia, a Finnish insurance company, and another that shows step-by-step data preparation and building and evaluating models using the AutoML UI. Now, Helly will also highlight deployment to OML services, Oracle Analytics Cloud, and Oracle Apex. And so with that, let's begin. As we said, today's session is Get Started with Oracle Machine Learning, Build and Deploy Your First Model. I'm Mark Hornick with Oracle Machine Learning Product Management and co-presenting with...
Hi, I'm Helly. I'm from Finland, CEO for Oracle Finland.
And so let's get right into it. Basically, when we start off with understanding what is it that we can do with machine learning, we'll talk about various use cases. And we can do this sort of as a horizontal set of use cases because most enterprises have customers, they have products, equipment, and employees. So when we think about customers, perhaps we want to do customer segmentation, where we understand what are the natural groupings of customers so that we can perhaps market to them in a more effective manner, to not bombard them with irrelevant messaging or products that they're not interested in. We might also want to understand what is the likelihood that a customer is going to remain loyal to us, or what's their lifetime value. And there are many different aspects of customer use cases that we can engage with. Products. What's the next best offer? Or cross-selling and upselling. We want to understand what is a relevant recommendation for a customer as opposed to just blindly hitting them with something that maybe they're not interested in. But of course, we might want to also do forecasting to understand demand and inventory projections as to how much product do we need to have in-house. Equipment is another one where predictive maintenance really comes into play, because if you have equipment and you don't service it in the right amount of time, perhaps you're incurring more costs because of damage or the need to replace that equipment. But if you do it too soon, you may be wasting resources as well. And there are other aspects for understanding the root cause analysis for problems that are encountered in processes or leveraging equipment, demand forecasting, as well as even just usage anomaly detection. How are your employees leveraging various equipment, and should we identify any unusual cases there? And in the case of employees, we also have what are the attributes of our best employees? What types of employees or prospects should we be going after for certain roles in the organization? Retention, which employees are likely to seek employment elsewhere, or which type of hiring practices should we have to attract the right employees to our environment? So there are many different types of horizontal use cases that we can work with. Now, these use cases are supported by a variety of machine learning techniques. And these machine learning techniques are supported in Oracle Machine Learning, along with other techniques as well. And we can start off with classification, where we're trying to understand, what are the categories that we can identify for lifetime value for a customer? Is a customer high, medium, or low? Or are they likely to prepay their loan? Yes or no? Perhaps is a customer likely to be loyal to us? Or are they going to churn? Customer acquisition. Should we extend an offer to acquire a particular customer or not? Now, some of these problems can be redirected as regression problems. So instead of predicting a category for lifetime value, perhaps we want to predict an actual numeric value. What is the dollar amount of the value of this customer to the organization? Now, regression can also be applied to forecasting, where we want to understand demand, perhaps sales and revenue, even how much money they're going to withdraw from an ATM. But if we have a time dimension to the data set, maybe it becomes a time series problem that we can take into account seasonality and trend and other aspects of the data. Now, in the case of clustering, clustering is one of those unsupervised learning techniques. And the idea here is to find the natural groupings of records or entities in our data. And some of them might be customer segmentation, right? We talked about that earlier, where we want to identify natural groups of customers so that we can more effectively target marketing messages to them, or do document classification, or even just exploratory data analysis to understand what are some of the natural groupings within the data that we're working with. Now, association rules is another one that allows us to say, if a customer did a certain action A and B, are they likely to do an action C? Or if they've bought a product A and B, are they likely to buy a product C? And so these are different techniques that can be brought to bear with data, especially looking at transactional data to support these type of analyses. The last one we'll touch on is anomaly detection, which is we're looking for unusual cases. And it doesn't necessarily mean, for example, that they're fraud or actual network intrusions, but that they might be interesting to look at further to determine whether or not they could be that. So with this as an introduction, I'm going to turn this over to Heli to share details about the customer use case, Finnia, and how they approached the problems with machine learning. Heli?
Yes, thanks, Mark. Well, Finnia is an insurance company in Finland, and they have been there for 140 years. Such an old company and always looking for new solutions and improving their business, and I really admire that attitude. So with Finnia, they are offering two kinds of insurances, non-life insurances and life insurances. All their customers are also their owners. So they have 360,000 individual private customer owners and 50,000 corporate customer owners. So quite an interesting place to work with. Mark, let's see what they have been doing. So some use cases Finnia has done so far using Oracle machine learning. Policy attrition. So they've been trying to predict the likelihood for a customer to leave, to terminate their policy. This is very useful just for many, many reasons. To maintain the revenue from existing customers, of course, or reducing policy terminations. And they also want to improve the revenue forecast accuracy by knowing their customers. And they want to reduce marketing budget for customer acquisitions. You know, it's always cheaper to keep your current customers than trying to find new customers. So it's good to keep your customers satisfied. So this has been very, very important for Finnia to understand those customers who might not be too happy as a customer, so that they are able to fix whatever the problem the customer is facing. For example, to have campaigns that they can offer to certain customers. Another use case is sales pipeline. So Finnia has been predicting the likelihood of a policy quote to be accepted, so that you can identify the potential or non-potential customers, and you can focus your limited resources on likely prospects. And you are not wasting your time. You are really saving your time and doing those things that are important to do. Sales pipeline factors means that they have been identifying those factors that are contributing to the customer accepting the policy offer. So what are those factors that will make the customer to accept the policy? So explore what if scenarios, offer specific campaigns, discounts, all kind of things that makes this particular policy much better suiting for the customer in case. Sales pipeline predicting likely deal value is similar to the first sales pipeline, but this one is about the money. So forecasting the total lifetime value of a policy in euros, or forecasting the revenue. When will you get the money finally from this new quote? So what is the expected timeline for that? Let's see the next one. So this is the solution from Oracle platform that Finnia has been using. They have been using Oracle Autonomous Database, which is of course a fantastic platform for machine learning. They have used Oracle Machine Notebooks for data exploration and solution development, and also to deploy the models. They have used Oracle SQL Developer to merge and transform data and perform feature engineering. And also Oracle Analytics Cloud to explore the data and to profile data. So these are all good tools for understanding your data and having your data in place. And then, last but definitely not least, Oracle Apex. Also to understand and profile the data, but absolutely most importantly, to be able to publish the models to end users so that they are able to see the results of the machine learning models. And here is some benefits that actually, when I was speaking to Fennia people, they told me these are the benefits that they see from this approach of machine learning. So machine learning enabled customer service improvements in the process. So it's more efficient and it's more accurate because of machine learning. Also, know your customer to better understand your customers. So who are your customers? What do they need? How can you serve them better? Improve data quality. This is absolutely important. So if you have a lot of data which is not good quality, it's worth nothing. So it's important to have good quality data and every time try to improve your quality. And they have been able to utilize the existing data better. So what's the point of storing data if you're not able to use it? And also increased understanding of what data should be acquired. So if there's some data missing in the database, what is it and where can we find it? Also develop customer segmentation profiles to understand the customers, and team has learned machine learning principles for developing new use cases. And in this coming year, hopefully monetary impact of using machine learning will show that this is definitely worth also in money-wise. Also, what we talked about lessons learned, what I learned was that data scientists should publish their models quickly. Don't wait until your model is 99.99999% accurate. You can publish it earlier to gain insights and ideas about the model. So you can't improve it if you don't see it in real life. And also understand the model quality and limitations much faster. So please publish the model more quick. Also, enable business users to see models in action early. It's good not just for me as a data scientist, but also for the end users, so that they can early give feedback and understand what can be done better. So it is very important to see it in real life to be able to stimulate new ideas and new use cases and so on. What they learned was that Oracle Machine Learning AutoML user interface is very useful because it makes it possible to create, test, and deploy machine learning models very quickly. And it provides usable model and baseline for further model tuning. We will see that later today. And also in database, Oracle Machine Learning Solution simplifies deployment and security. You can imagine that insurance business needs security. So machine learning inside the database maintains data safely in the database, and it stays there all the time. You don't have to move it anywhere from the database. So you don't need any additional security protocols or mechanisms to save your data or to secure your data. So having everything in a database and staying in database has been a very huge benefit.
Well, thank you, Heli. That was a great introduction and overview of what Fennia is doing with Oracle Machine Learning. And one of the questions that we just had in the Q&A was, is Oracle Machine Learning only available on Autonomous Database? And it couldn't have been a more perfect lead into this slide, because Oracle Machine Learning is available in a number of different database variants. So whether we're on Autonomous Database, Oracle Database on-premises, Database Cloud Service, Exadata CS, there are some differences, however. We have a SQL, Python, and R APIs that are available to access and use the machine learning capabilities. The Python and R APIs have some additional capabilities as well. And those are available on the various tools. What's different, though, is that with Autonomous Database, everything is pre-enabled. It's all there for you. In the case of Python and R with Oracle database, whether it be DBCS or Oracle database on premises, there is some installation that's required there, and I'll touch on that in a moment. Now, also on Autonomous Database, we have OML notebooks, which allows us to work with SQL, PL/SQL, Python, R, Conda, and Markdown interpreters. And this is built into the Autonomous Database itself. Then the OML AutoML UI, this no-code automated modeling interface that Helly mentioned and that she's going to demonstrate for us a little bit later. OML Services provides a REST interface and supports model management, deployment, and monitoring. We'll touch on that in a little more detail. And Oracle Data Miner was our original user interface. It's a SQL developer extension that has a drag and drop interface for creating machine learning methodologies. And you can connect to your Autonomous Database for that, as well as the other Oracle database instances. So with that, I want to just give you an idea of how do you get started with OML on Autonomous Database first, and then we'll look at Oracle Database very briefly. Now, to get started with Autonomous Database, of course, you can create, sign into your free trial account, or if you have your own Autonomous Database instance, use that. Provision an Autonomous Database, or if you already have one, you're ahead of the game. Then create an Oracle Machine Learning user, or extend privileges to an existing user. And then finally, sign into the Oracle Machine Learning UI. Now, the link here is for the Oracle Machine Learning Fundamentals Hands-on Lab. It's a live lab that you can basically walk through all of these steps and experiment with the various tools that we've talked about just a moment ago. Now, once you have your Autonomous Database instance, as admin, you want to log into database actions. And so you might see a page like this. And from there, you'll go under Administration. And for database users, you can either edit an existing user or create a new user, as shown here. And with that, the key element is to enable OML with this toggle, as well as web access. And that gives you access to all of the capabilities for Oracle Machine Learning on the Autonomous Database platform. At this point, your new user can log into database actions, and under Development, click on the Oracle Machine Learning tile, and that will bring them to the login page, where they log in as their new user. And from there, you go to the Oracle Machine Learning user interface, where there are quick action buttons to the AutoML UI, data models, data monitoring, notebooks, jobs, etc. And we'll be illustrating this for you in the near term. Now, if you have Oracle Machine Learning on Oracle Database, how do you get started there? Well, there are a couple of things. OML for SQL, the SQL API, is available across all database instances. And aside from just granting the necessary privileges, there's nothing else you need to do. You can start using your favorite SQL IDE and you're ready to go. In the case of OML for R and OML for Pi, you'll need to do some installation steps, both on the server and on the client. And those are clearly highlighted in the R and Python documentation. In the case of Oracle Data Miner, you would connect to your database and you'll need to install the Data Miner repository in your database, and that requires sysadmin privileges. And that's also detailed in the Oracle Data Miner documentation. Now, if you're working from, say, something like SQL+, you can create a user logging in as this DBA, create your user, grant the appropriate privileges, and then log in, and you're ready to go for the OML for SQL capabilities. Now, with that as our background, let's touch on the simplified machine learning process. How do you go about doing a machine learning problem? Well, it helps to have a framework within which to think about the steps that one should take. We clearly need to define the business problem. We talked about a lot of use cases, and a good deal of thought needs to go into what is the problem you're trying to solve? What is the data that I have available? We need to prepare that data set for model building. Once we have our model, we can use that for scoring. And then we want to deploy that model in production. This is a bit of a, I'd call it a cartoon, a very high level view of, what's involved. But let's look at a process, the cross-industry standard process for data mining, or CRISP-DM, and identify the steps a little bit more precisely. So the first one that's in this process is business understanding. We need to define the business objectives, and also, perhaps even more importantly, what are the success criteria? How are we going to know that we've accomplished what we need to solve our business problem? We need to have data understanding, collect and assess the available data. Now, if that's all in the Oracle database or accessible even in cloud storage, that simplifies that process as well. We need to explore that data and understand its quality. And in data preparation, then, it's necessary to perhaps address any data quality issues that come about. This might involve treating missing values or outliers, and even doing more massaging of the data to create derived variables. Imagine that we have a date of birth column, but we really want to be talking about age. Well, we'll have to do a minor calculation there to produce an age value, and that's perhaps what we want to use for our modeling process. We might even want to do feature extraction. Imagine you have a date column. We know when we contacted the customer contacted us. Well, maybe we want to pull out values because the specific timestamp isn't all that useful, but did they call in the morning, afternoon, or evening? Was it a weekday or a weekend, or other types of values that we can derive from that original timestamp? Now, once we have our data, we then do modeling. And this is where this quote unquote fun part starts, right? We have different algorithms. We have a certain set of features that might be relevant for those. We need to tune those models and assess the model quality. And for tools like the AutoML UI that automates this specific aspect of it, it makes that so much easier. And that's what we're going to talk about in a little bit. Assess the machine learning solution results and evaluate them against the success criteria, because it's really key to know that even if we got a good result, is it actually going to solve our problem? And once we're satisfied at that point, putting that in deployment. Now, putting it in deployment is really just the beginning of the problem. We also need to be able to monitor the data that's being fed to that model. Is that data changing or evolving? And also monitor the model accuracy, because models are known to degrade over time if the patterns in the data that's being fed to it are changing. We want to be able to catch that. And OML services allows us to do just that. Now, new data is going to be generated from this deployment process, and it sort of forms a flywheel effect. As we have more data being generated, we're going to feed that into building new models and then deploying those models as well. So that should give you an idea of the basic process that's involved. And the tools that we have with Oracle Machine Learning and Oracle Database and Autonomous Database actually allow us to address each of these areas specifically highlighted here. Whereas if we look at business understanding and evaluation, those are inherently human activities. And so we need to have the experts, the domain experts, to look at that and evaluate what's going on, but we can have tools that support our users in doing data understanding, preparation, modeling, and deployment. And so with that, we're going to switch to the specific use case that Helly's going to take us through, end-to-end solution predicting bicycle riders.
So my use case here is that city of Helsinki has IoT devices around the city to count the bicycle riders. So how many bicycle riders we have in each of these spots in the city of Helsinki. And the question here is, I have to predict the number of bicycle riders in Kaisaniemi station on defined day, so that the city will know how big is the effect if this area is closed for a certain day. So for that, I found a data set from the city, which includes data about number of cyclists in every day, or each of these days. Before you start, you have to define success criteria, because otherwise you don't know if you succeed or fail with your process. So in this example, we have defined that my prediction accuracy is the most important thing, and it will be measured with the R-square metric, and it should be at least 0.8, so that we can say that we have met the criteria. Also, it has to be very easy to deploy to production. So these are my success criteria for the project. So we start with data understanding and data preparation. So there's several tools for that. So my recommendation is choose the one that fits you the best. So there are plenty of tools. You can use SQL Developer or SQL Developer Web. You can use notebooks, Excel, third-party SQL tools, Python or R IDEs, different kind of tools. Just choose the one that suits you the best. Or you can use Oracle Analytics Cloud. Using Auto Insights or Explain will bring you a lot of knowledge about your data. So plenty of different kind of tools. The main thing is that you understand your data and you are able to prepare the data for the machine learning algorithms. In this example, we decided to use Oracle Machine Learning notebooks. So in this notebook, you can now see that we have the information is in day and hour level. So the datetime ID is showing the date and also the hour of number of cyclists. These are different stations where it's been measured how many cyclists we have, and then number of each station in particular time. What we understand now is that actually it's now on hourly level, which is too detailed for us because we need to predict how many cyclists per day. So we need to sum up the data to a day level. We also understand that actually date as information is totally useless. So as date, it means nothing if it's 1st of January or 1st of July. And if it's 1st of January 2020 or 21, it doesn't really matter anything. So the day as date doesn't mean anything. But actually, it would mean a lot probably if we use the day of week. Like Monday, is that different than Saturday? Do we have different kind of cyclist numbers on Monday than we have on Saturday? Or does the month affect the number of cyclists? Like in Finland, it snows. So probably June, when it snows less, it's going to be more cyclists than November, when it might be snowing quite a lot. So probably the month might be affecting. So these might be much more interesting features than the date itself. So if we go and sum up to the day level and we add the month and the day of a week to our data set, this is what we get. So we see in both this Excel kind of sheet as well in the charts that it does affect if it's Monday or if it's Sunday. So it looks like weekdays are much busier than weekends. And based on that, I would assume that a lot of people cycle for work, but that's my assumption so far. Also, if I see the month, I can see that the month also affects. It looks like January is not very busy, but August, September seems to be quite popular. And that actually backs up my theory about cyclists being those who cycle to work, because usually July, which I would assume is the biggest month for cycling, is usually the best weather. It's not so big because a lot of people are on vacation in July. So, but then I understand, oh my goodness, actually, the data I have about the other stations, I cannot use that for creating the prediction because I don't have the data when I'm creating the prediction. These stations are very close to each other, so it's like 5 minutes from each other, and predicting 5 minutes before makes no sense. So I would only use data that I have early enough to make valuable predictions. So I cannot use the information about other station numbers to predict one station number. This thing is actually called data leakage. So if the feature is not available at prediction time, you cannot use it when you are training the model. So what I'm going to do, I'm going to actually unpivot this data so that I will have a row for each station. So I will have the date, station, and how many cyclists I have for that day. I realized that this will remove my nulls, which is a good thing because null is not a good thing in a data set. Null means nothing and it's only confusing my algorithms. But I also realized the data set has zeros. And I am a little bit confused. What does zero actually mean? Does it mean that nobody is cycling on that day? I asked the business and the business tells me that zero actually means the same as null. The station was not in use. So I have to also remove zeros from my data set to be able to use it for training. So I'm unpivoting and removing zeros and nulls from my data set. And I start creating my first model. Here I create a new experiment. I give it a name and usually also give a comment because you will be creating quite many models. It's good to have some kind of description for your model. I select the data source that we just created. You can see there's different schemas, there's different tables and views, and I will select the one that includes the data we just created. The next step here is to define what will be predicted. Total cyclist number is the one that I want to predict. And as you can see, it defines it as regression problem. We are trying to predict a number. Additional settings include a couple of things. Maximum top models, so how many of your models you want to be seen. How long the run can last, and what kind of connection do we use for the database. I'm going to use high. And what is the measure we use to evaluate these different models? And we defined it's going to be R square. You can also see all the models that are in your database. You can deselect them or select them, depending what you want to do. And you also see the features, the columns that you have in your table or your view. And this one here is the one that we are going to target. When you're done with that, you are ready to start. Either faster results or better accuracy. I will choose faster results. I have actually come to conclusion it's also better accuracy quite many times. But anyway, we're going to use this one. And now it takes a little bit time to set everything up. It's preparing the run, and it's setting up all the tasks that it has to be doing before we are ready. The things it does: algorithm selection, adaptive sampling, feature selection, model tuning, and feature prediction impact. All these things are done automatically. Well, the experiment is ready. I have different kind of models created here and feature impact created for each of them. So let's see what we ended up with. So we have here completed, everything is done. You can see here how R square is improved. And from metrics, we can also choose other kind of metrics. All these are calculated automatically. And based R square, they are organized here. So the best model is neural network. If I go and see the features, the station seems to be the most important feature for prediction. Makes sense. If I go to one individual model, I can see how this one was affected by different features. So for this particular model, cyclist month seems to be the most important one, and then station, and then cyclist day. So this is how you can create your models quite easily. So what model means is that you are combining algorithm with the data, and you create a model. So I have created, the second one. That was the first model that was created. So what if I was not happy with it? The accuracy was not 0.8 like I wanted. So what can I do? What if I made a mistake with my months? What if I should have used season instead of month? So I divide my months into seasons: winter, spring, summer, and autumn. And this is how it looks like. So summer seems to be the busiest and winter seems to be less busy, which makes sense, right? After all, we are in Finland. So if I create a new model using the season data, I get a new R square, which is actually less than my first model. So my change from month to season was not a good choice. So it looks like my model quality is discrete. It's not as good as it was before. So obviously I should not be using season. I should be using month. So what can I do? I'm still far from my 0.8. Rain. It rains in Finland, and rain is definitely affecting the decision if I'm going to be cycling or not. So I found another data set which includes information about rain. So -1 means no rain, and any other value means rain. What if I use just this information? It rains or it does not rain? Well, that might be a good idea, but if you think about it, it will probably be a different decision for a cyclist if it's just a couple of drops or if it's pouring rain. So what if we use business understanding and we categorize the rain? So the business tells me, okay, -1 is no rain. But if it's between 0.3 and 0.9, it's going to be mild rain, and and if it's larger than 4.5, it's going to be heavy rain. I'm going to use that as an information, and I'm creating a new model using the same AutoML user interface. This time, my third model with the rain data is showing 0.79. which is already very close to my 0.8, but not yet there. So I need to change something more here. What can I do? It seemed to be a good idea to use the idea of using month or season. What about if I use day and weekday, weekend idea? So instead of using days, I use weekday or weekend. So I will set up my data set again, and I create a model using weekday or weekend information. And actually, the model is slightly better than it was before. So this seems to be a good feature for my model, but I'm still not on 0.8. So I need to find something more here. If I think about it, one thing that might affect my decision, should I take bicycle or not, could be temperature. You know, in Finland, it can be very cold. And that's probably affecting. So if your fingers are really cold or your head is, freezing, you probably don't want to cycle. So let's go and see if the temperature will affect my decision on riding or not. So here we will define, based on temperature, if it's cold, so the business tells me it's defined in Finland, it's defined cold if the temperature is below 10 Celsius. If it's between 10 and 25, it's considered normal. And please don't laugh. If it's more than 25 in Finland, it's considered hot. So this is how we see weather in Finland. And I should use exactly those business concepts that are valid in Finland. So I will divide my data set based on this. I will categorize it in cold, normal, and hot. And I built a new model. This time, my model accuracy is 0.8, exactly what I wanted. Of course, I want it to be even better, but this is enough for me to go to production with my model. So the best one seems to be neural network. Cyclist month seems to be the most important feature, with station, which is almost equally good. And then weekday, temperature, and rain. So they all seem to be affecting the prediction. This model is good enough.
Helly, there was a question earlier that I think might be relevant at this point. Does bicycle prediction have any type of real-time integration with external systems, like weather forecasting systems, to take advantage of that? And so I just wanted to ask at this point.
I will show it in the end. So when we are deploying the model, you will see it does have effects, because all these features that I need for creating the prediction needs to be available when I am creating the prediction. And the person who's creating the prediction is the end user. So I'm going to show you in the end how he or she will do it. But let's see here how I'm going to deploy the model. First of all, I'm going to rename it, because all these are stored in a database, but I wanted to have a proper name so that I can really call it from my wherever I want to use the model. So I'm creating the model, I'll rename the model with a proper name, and then I'm going to deploy it. For deployment, I'm defining the URI. Typing is not easy. And I'm going to define the version and the namespace. And if I want to share it with other users, I'm going to check this shared here. And I say, OK. Now it's been deployed. And you are able to call my model. You're able to use it. You find it from here. If you go to models, here are all user models, and here are those models that have been deployed. So this is the one we just deployed. If I select it from here, I can see the metadata of the model. So it's regression, it's using neural network, it's using cyclist month, it's using, and it's predicting total cyclist, and so on. And if I click here on the URI, I can see the open API specification of this model. So how you can use this model.
So just wanted to interject a little bit about OML services, as it might be new to some of you. The objective with OML services is to support machine learning operations, MLOps. And so It provides lightweight scoring using REST endpoints, and this supports both real-time data scoring and streaming applications. And it supports a range of machine learning techniques, whether it's classification, regression, clustering, or feature extraction models. And these are not only for the in-database models, which we would say are in native format, but also models that might have been built elsewhere, third-party models that have ONNX format representation. And with the OML services, you're only paying for the actual scoring compute. You don't need to provision a VM separately. That's taken care of for you. And the management of that capability is taken care of as well. In terms of the features, model management, whether you can store, organize, version, or compare your models, deployment, as we said, for real time, but we've also added batch scoring capabilities as well. So you can use the same REST interface to kick off that in a scalable manner. Monitoring, you can do this from the REST API, data monitoring and model monitoring. And we've recently released a data monitoring no-code user interface. And coming up is going to be a no-code model monitoring user interface as well. There's even cognitive text capabilities for topic and keyword extraction, text summary, and similarity using a pre-built model. So hopefully that gives you a quick understanding of the goals of OML services. Back to you, Heli.
So the question about the weather forecast and all that kind of thing. So to be able to let my users use this model, they need to have availability of weather forecasts. So here they have from Foreca weather forecast using REST API for as long as they have forecast, as long as we can do for any kind of predictions. So we select the day here, and based on the day, the weather forecast will tell us what kind of weather is expected for that day. And from the list here, I can select my Kaisaniemi station. And I can see that the predicted number of cyclists is 1224, station weight is negative, temperature weight is positive, and the weekend weight is completely zero. I can see the JSON request here and response. But if I go and select here another day, I have different kind of weather. It will show me that the station weight this time is negative, and the weather forecast is different than it was in the previous one. If I select another station like Kaivokatu here, the prediction is mostly clear. Weather looks pretty okay. And it says the temperature is the plus weight for my prediction, but the month is a negative prediction. But also I can go here and select, I have my Kaisaniemi station here. I can see for the whole period of weather forecast I have prediction numbers of cyclists for that station based on the weather forecast and based on the day and based on Kaisaniemi station. So definitely all the information that is used in the model needs to be available so that you can make predictions with the application. So this application is built using Apex and with REST API calls to another database, but it can also be in the same database, and then you don't have to use REST APIs because everything is stored in a database. Well, you can also use Analytics Cloud if you want. So I mentioned earlier that the models that we created using AutoML were stored in a database. The same database stored models can be used in Analytics Cloud as well. All you have to do is register the model. So you just go here, register model and machine learning models. You select from the list the model that you want to register, and you say register. Then you can use it with your data flows. So you just apply model and you apply the model that we have in our database. And you can save the data set also in a database and use it with Apex or whatever you want to use it. So the same model, the same data is not only accessible from the AutoML, it's also accessible from Apex or from Analytics Cloud or many other tools that Oracle is providing, because all the information, all the data, everything is in a database. And also, if I predict using OAC and I save the data set in OAC dataset, I can just create any kind of analytics of my data. So I can just use it in a way that I just want to do it.
So just to summarize some of the Oracle machine learning benefits, we've talked about having a simpler solution architecture and management. And in part, this is based on Oracle's converged database because you don't have a separate machine learning engine. This is included in your database itself. And so you can immediately take advantage of these capabilities without having to move the data. By eliminating data movement, you're also simplifying the process and taking advantage of performance benefits of having that data in the database with database parallelism enabled. You have multiple language APIs, SQL, Python, R, and REST available for you. There's also the automated machine learning capabilities, whether you want to use this through the Python API with OML for Pi, or as Heli showed us with Autonomous Database and the AutoML no-code user interface. Data and model governance comes through Oracle-enabled security. It's also a simple pricing structure. It's free. It's included in your database license if you're an on-premises user site. Or if you have Autonomous Database, it's immediately available for you to use. The algorithms have been designed for scalability and performance, taking advantage of database capabilities. And on Autonomous Database, elastic scaling is available as well. And finally, flexible development, test, and deployment. So whether you're in the cloud, on premises, or a hybrid environment where maybe you do some work in the cloud to take advantage of the AutoML UI and deploy models on premises or vice versa, you can do that as well. In the case of more information, one of the questions we had a moment ago was, are there any live labs available that would take us through these capabilities? And so the answer is yes. Not only there's certainly our webpage, our blog, GitHub repository that has code examples, notebooks as well. These office hour sessions, of course, are the past examples that we've highlighted through those sessions. But for the live labs, there's the OML Fundamentals hands-on lab. There's also an OML for Pi specific one and several others that you can leverage and work through at your leisure. Of course, the Oracle documentation link here is available. So with that, we can take some additional questions if you have any there. One question is, are we planning any session on Apex no-code features? So in general, I think Heli highlighted how you can incorporate machine learning into Apex, and there are some sessions where we've gone through this in even more detail. So Apex coming with no code. So this has to do with, say, generative AI. And the idea here is that we can leverage natural language to SQL generation and blueprint generation, leveraging generative AI models. And so definitely this is something that is on the horizon, as was mentioned at CloudWorld. We even had some demos of this at CloudWorld as well. So I think this is an exciting time to take advantage of this functionality as it rolls out in the coming year. Are these features available in Autonomous Database Dedicated? So Autonomous Database Dedicated supports the OML for SQL API. We do not today support the Python or R interfaces or the capabilities specific to Autonomous Database serverless. That means the OML notebooks, the OML services, and AutoML UI. Those are available through Autonomous Database serverless only. Well, with that, thank you, Heli, for a very interesting set of use cases and examples of how to use Oracle Machine Learning. Appreciate your taking the time to share your expertise with us. And we will look forward to seeing you at the next Oracle Machine Learning office hours.